Betelgeuse, a colossal red supergiant nestled in the Orion constellation, has captivated human curiosity for centuries with its deep crimson glow and immense size. Astronomers estimate that if Betelgeuse were placed at the center of our solar system, its sheer scale would engulf all planets up to Jupiter. This immense size signals that the star is nearing the end of its life cycle, poised to end in a dramatic explosion known as a supernova. In recent years, Betelgeuse has begun acting strangely. Its brightness unexpectedly surged by over 50%, propelling it from the 10th to the 7th brightest star in the night sky. This sudden flare sparked intense scientific interest. Was this a precursor to a supernova or just a temporary fluctuation? The implications are profound. If Betelgeuse were to explode, it could brighten the night sky enough to mimic daylight, offering a rare and extraordinary window into stellar death. A star's brightness depends on its size, temperature, and distance from Earth. Betelgeuse, with a radius over 700 times that of the Sun, is relatively cool, with surface temperatures around 3,000 Kelvin. This cooler temperature gives the star its iconic red hue. Its enormous size and relatively low temperature make it an ideal candidate for a supernova, which makes its recent erratic behavior even more compelling. Then, in late 2019, Betelgeuse baffled astronomers again by dimming to just 40% of its usual brightness, a change so dramatic it was visible to the naked eye. This prompted a wave of observations and speculation. Was dust obscuring the star, or was something more intrinsic at play? The idea of an imminent supernova took center stage. Using Chile's Very Large Telescope VLT, astronomers captured highly detailed images of Betelgeuse during this dimming phase. These revealed that the star had become visibly distorted. Further analysis suggested the dimming was likely due to a massive surface mass ejection, during which the star hurled an extraordinary volume of material into space, over 400 billion tons, far exceeding typical solar eruptions. This cataclysmic event, akin to a volcanic eruption on a stellar scale, disrupted Betelgeuse's pulsation rhythm and shortened its expansion period from 400 days to just 200, further signaling its growing instability. With the star's behavior becoming increasingly erratic, astronomers have intensified their monitoring, looking for any signs that Betelgeuse might be on the brink of collapse. When a massive star like Betelgeuse depletes its nuclear fuel, its core implodes under the force of gravity, triggering a supernova. This enormous explosion blasts the outer layers into space, producing a light show so bright it could be seen even during the day. The first indication of such an event would be a burst of neutrinos, tiny, nearly massless particles that travel faster than light and escape the star before its outer layers explode. These neutrinos would reach Earth hours ahead of the visible light. Once the explosion becomes visible, Betelgeuse could shine more brilliantly than a full moon, casting eerie shadows and illuminating the night sky for weeks. Such a supernova will be a once-in-a-lifetime scientific event, offering an unparalleled chance to study the death of a star in real time. By analyzing the light, heat, and radiation released, scientists could gather priceless data on stellar evolution, nuclear physics, and the origin of life-essential elements. To decipher Betelgeuse's strange behavior, researchers are employing advanced simulations to model the star's inner workings. These virtual experiments help them explore the complex processes unfolding deep within the star, potentially bringing us closer to understanding when and how this cosmic giant will meet its explosive end. By incorporating data from advanced observatories like the James Webb Space Telescope JWST and the Very Large Telescope VLT, researchers are gaining deeper insights into forces behind Betelgeuse's growing instability. Simulations based on these observations suggest that a massive gas bubble likely formed deep within the star, disrupting its pulsation rhythm. Thanks to JWST's exceptional capabilities, scientists have obtained an unprecedented view of the material Betelgeuse has expelled, revealing intricate formations of gas and dust encircling the star. These findings strongly indicate that Betelgeuse may be entering the final phase of its life, offering a rare glimpse into the end-of-life cycle of a massive star. Although astronomers estimate that Betelgeuse could explode as a supernova within the next 10,000 to 100,000 years, its increasingly erratic behavior hints that this timeline might be shorter than previously believed. The global astronomical community is now racing to document every detail of this cosmic drama before its inevitable climax. In late 2023, JWST turned its powerful gaze toward Betelgeuse and revealed astonishing new phenomena. Scientists found that the star, already unstable due to a colossal surface mass ejection, had undergone a rapid internal collapse. This was evidenced by noticeable shifts in the dynamics of its core, affecting the star's nuclear fusion processes. Prior to the collapse, Betelgeuse exhibited expansion and contraction cycles lasting approximately 400 days. Following the event, this cycle was abruptly reduced to 200 days, signaling significant disruption in the star's inner structure. These irregular pulses serve as a sort of cosmic heartbeat, indicating that Betelgeuse may be nearing the end of its life as a red supergiant. Astrophysical simulations further support this, revealing that Betelgeuse's core is growing increasingly unstable as it begins to fuse heavier elements. In this phase, the star starts producing iron, a critical turning point. Unlike lighter elements, iron fusion does not release energy. Instead, it leads to an accumulation of mass, ultimately triggering core collapse. Betelgeuse's dramatic and unpredictable behavior has sparked intense debate among astronomers about the timing of its eventual explosion. Some believe the supernova could occur within a few centuries, while others maintain it may still be millennia away. What is certain, however, is that Betelgeuse's time as a red supergiant is rapidly coming to an end. One of the most crucial signs that a supernova is imminent is a burst of neutrino activity, tiny, elusive particles that escape the core moments before collapse. Scientists are vigilantly monitoring Betelgeuse for any sudden spike in neutrino emissions, and instruments worldwide are on standby to capture this fleeting but vital warning signal. Detecting it could mark humanity's first real-time alert of a nearby supernova. Though Betelgeuse's explosion will be a breathtaking sight, bright enough to be visible during the day and rivaling the full moon in brilliance, experts assure us it poses no threat to Earth. Instead, its light could dramatically illuminate the night sky for weeks, casting eerie shadows and dazzling observers. For scientists, this event will be a once-in-a-lifetime opportunity to study the death of a massive star in real time. The story of Betelgeuse is a humbling reminder of how much we still don't know about the universe. This colossal star, which has fascinated humanity for centuries, continues to defy expectations with its dimming mass ejections and erratic pulses. Its potential transformation into a supernova is more than a cosmic spectacle. It's a gateway to understanding the life cycles of massive stars. Unlocking its secrets may ultimately deepen our comprehension of stellar evolution, galactic dynamics, and the cosmic forces that shape the universe itself. The forces that shape galaxies also enrich the universe with essential elements that ultimately make life possible. Each discovery deepens our understanding of cosmic history and our place within it. Thanks to powerful tools like the James Webb Space Telescope, JWST, and ground-based giants, such as a Very Large Telescope, VLT, we now peer into the cosmos with unprecedented clarity. These instruments allow us to simulate stellar processes, examine the dynamics of stars, and look billions of years into the past, unraveling the very fabric of reality. For scientists like Neil deGrasse Tyson, such discoveries fuel a sense of awe and urgency. They challenge us to push the boundaries of what we know and inspire us to keep exploring the vastness of space. So next time you gaze at Orion's belt, remember, one of those shining points marks the turbulent journey of Betelgeuse, a massive red supergiant possibly nearing the end of its life. Could we be witnessing the star's final moments before a spectacular supernova? Or is this just another enigmatic chapter in its long life cycle? Let us know your thoughts in the comments, and don't forget to like, subscribe, and turn on notifications for more mind-blowing cosmic stories. Until next time, keep your eyes on the skies. As astronomers continue to observe Betelgeuse, it's clear that this star is far more than a beautiful speck in the night sky. Its unusual behavior offers a rare window into the intricate mechanics of stellar evolution. Every fluctuation in brightness, every mass ejection from its surface, and every irregular pulse brings us closer to decoding the life cycles of massive stars. One of the most fascinating aspects of Betelgeuse is that it's currently in a relatively rare evolutionary phase. As a red supergiant, it's nearing the end of its stellar life. But the path to supernova is anything but simple. The causes behind its unpredictable behavior remain a topic of scientific debate. The massive surface ejection observed recently may be one dramatic episode in a much longer and more complex sequence of changes leading to its eventual collapse. Even more compelling is what Betelgeuse's future explosion might reveal. The death of a star like this one could shed light on some of the most profound mysteries in astrophysics, such as the nature of dark matter, the rate of the universe's expansion, and the conditions under which new stars and planets are born. Such revelations would refine our understanding of cosmic evolution and help reshape our models of a universe. The global astronomical community is closely watching Betelgeuse as part of a broader mission to study the end stages of massive stars, an elusive phenomenon often too distant and fleeting to observe. That's what makes Betelgeuse so special. Its proximity and visible changes offer a rare, real-time opportunity to study what typically remains hidden in the vast depths of space. Yet, one question remains unresolved. How much time does Betelgeuse have left before it goes supernova? The answer remains uncertain. New data constantly reshapes predictions. Some astronomers believe the explosion could happen soon, while others suggest it might still be thousands of years away. Regardless of the timeline, the anticipation is electric. For now, researchers continue their vigilant monitoring of Betelgeuse, collecting every bit of data they can. From the JWST's advanced infrared observations to the powerful optics of Earth-based observatories, the world's top scientific minds are working to decode the secrets of this colossal star. Their findings will refine our knowledge of stellar death, galactic formation, and the forces that govern the cosmos. Betelgeuse's unfolding story is a striking reminder of the universe's vastness and complexity. While countless stars undergo incredible transformations, few offer such a clear and accessible look into a star's final chapters. Its impending supernova, whenever it occurs, will be a historic event, one that could unlock new understandings of stars, galaxies, and the very nature of space itself. For astronomers, it promises unprecedented opportunities for discovery. And for the rest of us, it's a humbling glimpse into the awe-inspiring beauty and mystery of the universe we call home.